Hi. In this video, we'll be doing a brief introduction to inequalities. So I'm assuming that if you are watching this video, by now you've probably done some work with equations. So you know what an equation is and you're probably comfortable with it. All right, so let's step outside that comfort zone a little bit and stretch you a little further. All right. So before we start talking about what an inequality is, I do want to make sure you remember what our inequality signs are. You may have learned this before, but if you didn't, don't worry about it. I'll go over it here. So we have 4 signs that we use to represent inequalities, and I'll go over them right now. This one here means less than. This one means greater than. And then we can add another element to these signs. So if we take the less than sign and we put a line underneath, that means less than or equal to. And we can go ahead and do the same thing for the greater than sign and put that line underneath, and that means greater than or equal to. Now, some people struggle with the direction of the signs and forget which one means what. So here we go, just a little bit more of an explanation to that, and like a little bit of a memory tool that I use to help me out. So when you have the less than sign, just keep in mind whatever is over on the left is less than whatever is on the right. Here, whatever is over on the left is greater than whatever is over on the right. And again, I'm going to show you something that I use to help to remember these things. Whatever is over on the left here, the expression on the left is going to be less than or equal to whatever is on the right. And right here, whatever is on the left is greater than or equal to whatever is on the right. And that's how we read these signs. But how do we remember that that's what those things mean? Well, different people use different tools, and this is the one that I've found most helpful in my math life. So notice that the pointy side is the small side, and the other side of this is the big side. All right, because it's taking up more space. Whatever is on the left, in this case, because that's the small side, is the smaller thing. In this case, the small part is over here, but the big part is over here. That's bigger. That's just a point. It's small. So this on this side is greater than what's over here. And so that's how I remember it, and it's worked for me. If that doesn't work for you, maybe you could try something else, but it's super important to remember what each of these symbols mean. Okay. Now that we've spoken about that, let's get to the good stuff, which is to actually look at an inequality and talk about finding the solution of an inequality. All right, so an inequality, you may remember, let's look back at equations for a second. An equation is a mathematical phrase in which one expression is equal to another expression. So now an inequality is also a mathematical phrase in which one expression is related to another expression. So we have 2 expressions, an expression on the left, an expression on the right, and they're related in one of these ways. So one expression could be less than or equal to the other, one could be greater than the other. So 2 expressions are related in one of these 4 ways. So an example of a inequality is x plus 5, that's one expression, is less than or equal to 11. That's another expression. The 11 is an expression and the x plus 5 is an expression, and they have that relationship. All right, so if you want to figure out the solution of an inequality, we cannot just pick one number, because there are multiple numbers that make this inequality true. So for example, well, let's look at something that possibly makes it true. Does 6 make this true? Well, if you solve this as an equation, you'll realize that 6 does make it true, because 6 plus 5 is equal to 11, and this means less than or equal to, so that works. But 6 is not the only thing that makes it true. All right, does 5 make it true? 5 plus 5? is less than 11? Yes, it's absolutely true. Is 4 true? Yes. 3? Yes. So there's so many numbers that are true. So what then do we do if there's so many numbers that work? Well, that is one of the things that I want to make sure that you leave this video knowing. The solution of an inequality is actually an inequality. So the solution of an inequality is also an inequality. So how do we solve an inequality? Well, this one is a particularly simple one because it's just dealing with addition. So there's some addition, and solving it, we might need to do some subtraction, but there's nothing else to this. When you have a simple inequality like that, solve it exactly as you would an equation. Keep the same sign that we already have and solve it exactly like you would solve an equation. So in this case, we have x plus 5 is equal or less than or equal to 11. And we're trying to isolate the x, and right now 5 is being added. The inverse operation of adding 5 is subtracting 5. So we're going to go ahead and do that to both sides. And we get that x is, and look at this, I'm going to keep the sign the same, less than or equal to 6. And that is actually the solution to this inequality. Now, if we take any value of x that is less than or equal to 6, it will make this expression true. This inequality true. All right, and that's what we want. So that's how you write the solution to our inequality. But there is one more thing that I want to show you before we close this video, and that is how to graph an inequality, because you should be able to give the answer in two ways: written, as we have done here, and visually on a number line, which is pretty cool. All right, so let's look at how to graph inequalities, and then we'll be done. Okay, so we just got an answer, x is less than or equal to 6. So let's start off by looking at that one and seeing how we should graph it. So when you're graphing an inequality, you're going to use a number line if we have just one variable, as we do here. And on our number line, we're going to make sure that we have this value somewhere on the number line, preferably not on the end, because you want to see what is happening with that number. So I'm going to go ahead and put 6 on our number line and then count backwards and forwards from that 6. So I'm just going to stick this right here. It doesn't have to be right in the middle. And I'm going to try to make it look as neat as possible. And then count to the end of the number line, then count backwards to the end of the number line. So 5, 4, until I have no more space. As long as we get 6 to fit, we should be all set. And so now x is less than or equal to 6. So that means x can be 6, right? X can be 6. So I'm going to put that as a point here because it can happen. And notice I shaded the point because it is a point on our number line. And x, it can also be anything less than 6. So less than 6 is everything going in that direction. So I draw a straight line with an arrow pointing to the left to indicate that x is 6, as well as everything less than 6. All right, let's do one example really quickly for each of the symbols that we learned on the previous page. So let's say let's use a different variable. N is greater than 2. Doesn't matter what variable I use. Get the number line in. Make sure that 2 is somewhere on the number line. Doesn't matter if it's in the middle, but somewhere on the number line, preferably not the end. And then count forward, 2, 3, 4, 5. Notice I forgot my arrow. I'll just stick that on there. Count backwards, 1, 0, -1, -2, -3. The arrows indicate the number line goes infinitely left and right. And is greater than 2, but notice here that n is greater than 2, but it does not include 2. It cannot be 2. There is a hole at 2, meaning if there is a hole at 2, then we need to show that there is a hole at 2, that it does not include 2. But it's everything that is greater than 2, so we draw the line and the arrow going to the right. All right, I'll go through the next two a little bit faster now that I think we're getting a hang of this. All right, so let's use a different variable. P is less than 1, And so we have our number line. 1 is somewhere on the number line. 1, 2, 3, 4, 0, -1, -2, -3, -4. There is a hole at 1. It does not include 1. It's less than 1. We go that direction. And finally, an example using the greater than or equal sign. All right, t is greater than or equal to 0. So we have a number line. 0 is somewhere on the number line. Count 1, 2, 3, -1, -2, -3. It includes the point 0, so I am going to put that point, make sure it's clear that that point is included, and t is everything greater than 0. The arrow goes to the right. All right, and this is how we graph our inequalities. Now we know how to solve very, very simple ones and graph them. And we're going to move on to another video where we're going to learn how to solve more difficult inequalities. So stay tuned.